Hello, I'm Guido Hoos, training manager at Shining3D, and today I'm going to show you how to inspect a part using a template in Shining3D Inspect software. So first of all, of course, we have to scan the model using a suitable scanner. So I have my little favorite scanner with me again, the FreeScan Combo Plus, which is a perfect device for scanning my model. And next, we just can start scanning the model. And since I'm a lazy person, I let the model move itself and let the scanner do the rest. So first of all, we have to generate a marker file that helps the scanner locate the position of the file. And as you can see, the markers on the screen are already also judged to see if they are good enough to scan the object, or if you have to rescan still a little bit. As soon as you have enough points scanned on the model, we can optimize these markers, which helps us being more accurate, and then switch to mesh scan and do our settings for the resolution, for example. And as soon as you confirm that, we can start scanning the object. We get a preview just to find a perfect position and let the scanner do the rest. As you can see, it's quite fast. The data acquisition is really nice. And there we go. Maybe a little bit from top. After that, we can just clean up the data a little bit. In here, I will make my living easy, just cut something from below the model.
Which would be simply selecting some data in here. You can see I'm selecting much more than would be needed, but I'm going to scan the model also from the downside. Additionally, I can also unselect some data if necessary, as you can see here. And there we go. Then can simply turn the model and scan the lower side by generating a new project file. And go back to scanning. Also here makes sense to get the new markers. Again, optimize and scan.
Okay, next we are going to clean up the data on the screen by selecting the model on a specific part, use connected domain, and invert the selection. After that, we can immediately delete everything that is unwanted. And then we do have two different sets of data that need to be aligned. That's what's going next. So we have to use a fixed and a floating position. And these positions have to be now aligned to be in a perfect position. And that is done by this time manual selecting of marker points. So you can simply select those points on the model. Quite easy. I'm going to use at least 4 points here. And after that is done, you can see that the model is perfectly aligned. It's aligned within the noise of the scan data. Wonderful. So after you accepted that, we do need to recalculate or to calculate the mesh, to optimize the mesh. There are some standard settings you almost can use every time. And by recalculating that, marker holes will be filled and we will get a perfect volumetric model that can be used in Shining3D Inspect software for inspection of our model. So next would be to save the model file that is perfectly shown in here. And export it to a position on the hard drive that is used for it. There we go. And that's basically the scanning part of life. And now it's going to get fun within Shining3D Inspect software. Here's how to create an automation template in Shining3D Inspect. First, we have to open an automation template. That's quite easy. Simply click on New Template, select your nominal file and open it. 3D Inspect will automatically generate a mesh as a tessellated CAD file and offset it a little bit, so we can also do an alignment the way it is needed. Now in our case there is a pre-alignment first, so we do that with a best fit alignment. Simply click on preview and the part is aligned. Click on confirm, and now every triangle has an according surface that can be used for automatic feature generation. In the following parts, you don't need to see the mesh anymore, so we can keep our screen nice and tidy. Next step would be to generate features on the part that are used for alignment. I will generate 2 circles and 2 surface points in order to align the part the way it should be. So first of all, I would generate 2 CMM points on my part, one here, one here. Note that the surface direction in the selected point is not parallel to any main direction we have in here. Second is that I want to have those 2 circles. Therefore, I'm going to generate 2 cylinders first. Simply click on the surface, extract the measured feature also, and confirm. Same in here. So let's put that in here, same in there, and confirm. Also here, the measured feature is generated automatically with the nominal feature. So next is that we might want to have the plane also, this time as a single plane, and confirm. Next is that we could generate some circles in here, and I will do that from features, plane and cylinder. So we can get our cylinder 1 and plane 1 for the first circle, and same thing from cylinder 2 and plane 1. So already now we could clean up the screen a little bit, but since these elements are just used for alignment, I will keep them on screen and directly will continue with my RPS alignment in this case. So in here I take my circle number 1, align that to X, Y, and Z. Circle number 2, this one just in Y and Z direction, and the remaining 2 points in here, they will be just normal to the surface, as you can see in here. Since I have, at least in Z direction, more than 3 points, there's also possibility to add tolerances and weights. So next thing is, of course, that we can do a preview. There's a thing that, of course, we're using the tessellated mesh for the generation of our template. We hardly will see any deviations in here. That comes later if you compare it with a real scan. In here, it just shows that the alignment is perfectly done. And as next, since all the features we generated are still in best fit alignment, I'm going to simply select all my features in here and will group them. Let's do that one by one. Here we are. This group can be named best fit alignment or whatever you think it should be named. And when that is done, simply hidden. So my tree is nice and tidy again, and the screen is also easy to see. So since the alignment is exactly what I wanted to have, I can also hide that, which is done on the right side of the screen. In label display, simply hide it. Next, we might want to have a comparison, for example in 3D. Therefore, simply select your tolerance to be shown. Let's make that 1/10 of a millimeter, and your maximum range ±1 millimeter. Click on preview. You can see that in here you can also set some annotations on the screen, but right now these annotations are just to visualize the exact deviation at the selected point, so they are not coming up in the report. There we go. Simply click on confirm, and the 3D comparison is already done. Of course, we can also add that to the report. Here we are. And after it's part of the report, of course, we can hide it again and continue with the next comparison, which might be some comparison points in here. These points are definitely part of the report, and they have also very nice definitions in here. So we can, for example, set the radius of the inspection area. Let's make that a little bit smaller. And also the maximum distance, which can be also a bit smaller. Additionally, of course, you can set the tolerance again. There we go. And then set the comparison points. Of course, we should show the mesh for that. Maybe make the radius a bit bigger. There we go. Depends on the size of the triangles, and that is a tessellated mesh, so it might be that the radius should even be a bit bigger. Let's make that 2. And all points are evaluated. Later on, our mesh might be a lot more high resolution, so we could change the parameters down again. So here we do have our inspection points, and also these points of course can be added to the report. And after that hidden, of course, we actually don't need them anymore. So next is some featured creation, and since we changed the alignment, we have to do the circles again, because the circles 1 and 2 are still in best fit alignment, so they cannot be tracked by measurements in RPS alignment. But since generating features is quite easy, because also the extracted feature will be created in a nice manner, we can do all the cylinders quite fast. Next would be the plane again. And of course our circles from feature. And in here we do have all the cylinders, also the cylinders in best fit alignment, so we should be aware that the whole thing starts with cylinder number 3 and plane number 2. Here's our circle in the current alignment. And so on. There we go. Since this is a lot of geometry on the screen and we don't need actually everything in here, we can also hide or group again some features. For me it would be all the cylinders and plane number 2, which can be grouped in a new group. Let's call that help geometry, and compressed and hidden. So now I do have only the important things on my screen, and I can start in dimensioning these. So in here could use point-to-point distance and select my features here. So let's start with our circle number 3, which is this one, and let's see, that's circle number 9. It could be a 3D distance, but if needed, you can also change that to an aligned dimension, and you will of course get a result directly on the screen in here. So let's log the dialog and confirm that. Next one would be number 4 to number 8. That's the next one. Here we are. And then we have now 5 to number 7. Confirm. So that's that. And for an additional measurement, I also would like to have the distance of the center circle according a line between those two circles. Therefore, I need a new feature, which is a line from 2 center points. And I can do that from circle number 3 to circle number 9. There's my line. Confirm. And we can see that this line also has a measured value because the features I created it from also have measured values. So that is tracked in a very nice manner by the software. And next I can jump back to dimension and add some more features in here. So that would be a point to line dimension. The point is our center circle, which should be circle number 6, and the line is line number 1. So it gives me directly a 3D distance, but also in here I can choose the direction to be along an axis. Confirm that, and there are a lot of measurements again. In here I could set all my features I used for dimension on the circles and the line to be in another group. So let's call this group top view dimension, something like that. And combine them, maybe hide them. So we have our distances in here tracked, and also that of course can be part of the report. Add to report. There are a lot of things more you could do in here. You can also add tolerances to the part, of course. And finally, you can generate a report. The report will be shown on the screen. That's also the template for later on reports. You have all the things in here. You have your comparison points in good, no good. You have your measurements and the results. And when that is done, the only thing you have to do is to go to File again and save the template as the template name you want to do. So save that, and your template is done. So if you have an empty screen and you want to inspect this part again now, simply go to Project, create a new project from a template, and you can select the template file, which is this one. And of course you have to select a scan file. So let's see, what we do have in here. There's a test file, and confirm. So this will generate the complete measurements and also the report. So the only thing you have to do is to preview the report and export the results. And that's all you have to do for the template generation and the execution for an inspection template. Thanks for viewing. And that's it for today. Thank you for watching, and I hope you will have a lot of fun using our Shining scanners.